So I don't know if there are many great things about debugging distributed systems. It is actually really hard, and it's never fun unless you find a bug and you fix it, in which case you feel good. So thanks all for being here. Thanks all for joining me in this very nice walk to remember. Where we're going to talk a little bit about debugging a distributed system, as it was hinted before. Just freaking wire. Okay, I'm good now. There's a link to my slides on the slide already, because I'm on top of my shit today. So you can already access the slides if you want. Debugging a distributed system, as I said before, it's not really an easy task. It takes quite some knowledge about your system. You got to be, of course, familiar with it. And that is indeed a work to remember. And all the times I've been debugging a distributed system, specifically OpenStack in the last couple of years, 4 or 5 years, there's always something new, there's always something different that happens, and it's always good to remember what you did before so you can do it again later. And of course the title comes from a movie that it's called A Walk to Remember. If you have not seen it, don't go, just like forget it. Spoiler alert, the girl dies actually, so there's no point in watching that movie. But that's me. Yeah, shit. I don't know what they call it, A Walk to Remember. She dies. Anyway, so yeah, that's me. Feel free to interrupt me at any time if you have questions. I don't really mind to be interrupted. I want this talk to actually be a little bit more dynamic because it is a general talk about debugging distributed systems. It's not actually very specific to OpenStack. It does mention OpenStack, and I use OpenStack a lot to rant about the crap that happens in distributed systems. But it's actually pretty generic. That has some company perspectives. It's had some team working together debugging this shit, and it also has some mentions some tools that you can actually use to debug OpenStack. Thank you all for being here. I'm still working at Red Hat. I'm a software engineer there. I work on OpenStack actually most of my time, like actually all of my time. I'm part of a technical committee. I used to be Glance's PTL for at least one cycle and the long-term Glance ranter ever. So you probably, if you know me for that. That's my Twitter handler. If you want to follow me, please do. If you like this talk, I love feedback. So if you like this talk, please tweet me or email me. That's my email. If you don't like this talk, that is not my Twitter handle. That is not my email. Don't say it. I don't care. But anyway, if you really feel like you have to say something, just feel free to do it. I'll just have to ignore you. I'm just kidding. A few disclaimers. I'm Italian. I move my hands a lot. I talk fast, I talk loud, and I said really bad words. So, and I already said like shit like 4 times already. So definitely not against you, and I hope I'm not just, going against the code of conduct. And if I am, well, too late. I'm already here. So 4 main topics for today. We're gonna go through like 4 different sections. What are we doing here? Which is something we all have to ask ourselves whenever we're gonna debug a distributed system. High to low context. I'm going to explain a little bit more about that later. The root cause analysis, which is probably the word that every project manager loves, is like, tell me what's happening, tell me the RCA of whatever you're debugging. It's like, there's not root cause, man. It's like, I don't know, it's a distributed system, everything, it's everywhere. But yeah, I actually like, analyzing what's going on in the distributed system, it's fine. Finding the root cause of that problem, that's the hard part. And sometimes there's not even a root cause, and we're gonna go through that as well. And then we're gonna bring everything home. You know, like after spending hopefully just 1 hour, and hopefully not like an entire month debugging an issue, we're gonna bring results home, and we're gonna analyze them and hopefully learn from them. Or not, because we love masochism, I guess. So again, 4 main topics. What are we doing here? High to low context, root cause analysis, and bring it home. Follow the acronyms throughout the presentation. They are in the bottom corner and on the right. It would be great if you actually remember what they mean. If you don't, it's fine, because I don't think I even remember those. But that's basically why I have so many slides on this. I just want to set expectations. I want to make sure the context is set. I could go forever on this and just burn my 40 minutes going through this context, but I won't, because I know you want to know how to debug a distributed system. So what are we doing here? it's kind of funny to have to ask yourself what are you doing when you're debugging a distributed system, right? You get a call at 4 a.m. in the morning, hopefully not, and you say like, "Oh, the system is down. We need someone to actually know what's happening here to tell us what's going on and to bring it back up." So there's already a key there, right? We need someone that knows the system, that knows what's going on in the environment, to tell us what's going on there, so to actually get the root cause analysis, and to also bring it back up in a working state. Which one is more important? Do you want me to tell you what's going on in the system, or do you want me to bring it back up? Which one should we do first, right? If the answer is, tell me what's going on, because I don't want it to ever happen again, well, it might take me a month to actually tell you what's going on. If you just want me to bring it back up, I can just reboot the freaking server, and it'll hopefully work if the data is still valid and available, and it didn't burn down to death. So, even though like, we gotta be super clear on that. And there are different questions that we probably have to ask ourselves whenever we are gonna start debugging a distributed system. One of those is what kind of issues we're facing. In a distributed system, I really hate classifying things that much, although I actually worked on big data applications before joining Red Hat. Big data applications. But we do have to classify things from time to time. And one thing you have to answer when you start debugging a distributed system is, what is the behavior we're seeing here? What's going on here? Are we trying to debug performance issues? Are we just seeing the system misbehaving to some extent for some reason we don't know? Or are we just seeing random things happening that we have no fucking idea what they are? So you gotta know, like, if the system is just being slow, there are many things that could be causing that lack of performance in your environment. So you gotta be aware of where you wanna look before, first, what exactly was the operation that was executed that made it slow. And the same thing applies when you see some actual problems and actual misbehaviors in your system. So you gotta know what you wanna do. And the fact that you are seeing performance issues doesn't mean that your service, your environment is not misbehaving, right? So one of the reasons I hate to classify these things is because you have to have an open mind when you're going to debug a distributed system, and you got to know that any of the things or all of them could happen at the same time, right? A good example is, we're going to talk about our beloved RabbitMQ here, is that in one of the cases that I was helping debug, I used to do a lot of things on also messaging, and debug a lot of RabbitMQ issues. So if you see a lack of performance in your RabbitMQ cluster, and you let me put it this way. So we had this case where we had a customer telling us, like, well, the system is not behaving, and at some point it just gets stuck, and we have to reboot RabbitMQ because, I don't know, like the queue fills up, and it's all our memory, and we're fucked, and all the system is down, and we don't have customers. We're like, okay, so you're rebooting the RabbitMQ. How many times do you reboot it per day? Because that's one question, like, well, no, I reboot it like at least once per day. Okay, that's bad, that's terrible. You shouldn't be doing that. And they said, like, well, like the queue fills up. And it's like, well, what operations are you doing to actually make that happen? And the answer is, well, we actually don't know. So go to the logs, get the logs, see what's going on, try to be there when RabbitMQ fills up and when it dies, and look what messages were there. So the answer, like, just to make it short and be able to move on, was that they were using this other software to actually get metadata out of Nova, and they were querying Nova's API. And Nova's API was filling up RabbitMQ with a whole bunch of operations it wasn't expecting, but that was not the real issue. So we were actually hitting Nova, and we were like, God damn it, Nova, you again. And it was like just going through the things that might happen. And it turns out that there was this thing in Oslo messaging that was not releasing the connection, so at some point it was not consuming more messages, and of course the queue filled up and RabbitMQ died. So, you start debugging from RabbitMQ and you say, well, we have performance issues because at some point it goes real slow. And turns out when you look at it, RabbitMQ is like dying and you're going to eat that rabbit for dinner. And then you have to kill it, you reboot it, things go back to normal, and you don't really know what's going on. So you have to have an open mind. But definitely you got to know what kind of issues you're facing. You have to know what you're expected to do, which is what I said before. Are you expected to bring the system back up to a working state? That's most of the time quite easy to do. Are you expected to know what's going on exactly in the system? And I have another example for this. So we were debugging this, again, RabbitMQ issue. And I'm going to talk a lot about RabbitMQ. So we were debugging this RabbitMQ issue. And the customer said, we're seeing from time to time, like during the day, that RabbitMQ loses connection, like Nova loses connection to RabbitMQ, and we have to reboot RabbitMQ. We have to reboot Nova. I don't remember. We have to reboot Nova to actually reconnect to RabbitMQ and get the system back to a working state. And we're like, well, like that shouldn't happen. We are working on distributed systems. The distributed system, one of the rules is that it has to be tolerant to failures. If it is not tolerant to failures, it's just pack up and go home, because that system is actually not working very well. So we were like, okay, so that's not good. What's happening? Let's look at what's happening. And it's like, well, like it actually loses connection, and when it tries to reconnect, it is failing to reconnect to RabbitMQ. And we're like, okay, so I don't know what's happening there, but at some point, the network between Nova and RabbitMQ is failing, and that's causing the disconnection between those two services. And as far as I am concerned, as an also messaging developer, also messaging is not reconnecting correctly to RabbitMQ. So I went upstream, found the patches, blah, 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 backport, and then make it work. And after we applied that patch, actually, Nova reconnected correctly to RabbitMQ. And they were like, well, but we still don't know what happened. And I was like, you didn't ask me to know that. You asked me, fix this. I want Nova to reconnect to RabbitMQ, and turns out it is reconnecting. So my problem is actually fixed because I'm a nozzle messaging developer. And it doesn't mean that I don't go, outside my realm to actually help other people. It's like, you gotta know what you're expected to do. And they were like, well, we wanna know what's going on because there's actually a network issue. And I was like, well, I'm not a networking guy. Turns out I work on storage. And they were like, well, there's a problem in the kernel, I want to debug it. And I was like, oh, well, if you want to go down in kernel land, that's fine. But it's not my responsibility. So it really depends on what you want. If you really want to know what's going on in the system, it can take a long time to actually debug it. And if you want to go into kernel land, well, it's gonna take you forever, but you may actually get something out of it. So make sure that the right people is involved. Like I said before, in that case, I was an also messaging guy and I was a storage guy. And they called me to this debugging session because I had the knowledge in that area, but we also had people from other areas because we were seeing these misbehaviors around it. But don't try to be a hero here. If you're pulled into a debugging session and you don't have the knowledge, if someone calls me to debug Neutron, we're in trouble because someone has to explain Neutron to me first so that I can actually be useful there. So don't try to be a hero. If you are not familiar with the context and the topics area you're trying to debug, just call someone else. Call the person that is going to do that for you in a better timing, I guess. And don't pull the entire freaking company to a debugging session. So if you have customers and your customers have problems, don't call your entire OpenStack team to debug a single customer's problem because you don't need them all. Just bring the people that are actually knowledgeable in the areas that you have to debug, and things should go better, I hope. So, hike to load context. Are we good so far? Questions? Okay, are you all awake? Yeah. Oh, nice. I did not expect that. Assume you're working in a low context environment. So who's familiar with the high context, low context, cultural categorization, I guess? No one. Okay, I'm going to go through that. So it turns out there are cultures that are high context and there are cultures that are low context. Cultures that are high context, they just know what's happening. They don't need anyone to explain them what's going on. If you go to a city and the signs are not super clear and people just seem to know what they're doing and where to go, and they don't need anyone to actually point at things to know what they are. Well, that's a high context culture. If you go to a low context culture, everything is like written down everywhere. Like there are 5 signs telling you that's a city hall, so that you actually know where the city hall is and what the name of the addresses are and all that kind of things. Well, if we get these 2 contexts and we apply them to debugging a distributed system, and especially when you have people from different cultures, and by culture right now I mean people working on different projects that are all part of the distributed system. I'm not even talking about I'm Italian and you are Swedish or that kind of things. I'm actually talking about people in the same company that just have different knowledge in different areas that are trying to debug the same problem, right? So when you're debugging a distributed system, you have to make sure, and I probably learned this the hard way, you got to make sure things are kept in low context. What I mean by this is make sure the things that you're doing and the things people are supposed to do are written down somewhere. Do not assume anything about anyone, and do not assume anything about the things that have been done in the system or in the debugging session. So when you start debugging a distributed system, you start building like random hypotheses of what could be happening in the system, right? Someone calls you and says like, well, the rabbit is not behaving as I would expect it to do. And you're like, well, it could be this, it could be Nova, it could be, I don't know, Glance, and your instances are dying, and I don't know why, but it could probably be that you just ran out of memory or something like that. You just start building random hypotheses of what could be going on in the system until you actually put your hands on it and you start reading blocks and you start diving into it and you build more concrete hypotheses until you actually find the cause. In this process, you gotta write everything down. You gotta make sure that you have everything in a low context fashion, so that if someone else has to take over or someone else has to join you, that person will ramp up quickly enough to actually be useful and don't have to spend the same amount of time as you did to know what's going on and to actually join you in the debugging session. And do not make assumptions about the steps that have been taken so far. When you start working on or debugging OpenStack or a distributed system in general, and you just join the party late, don't make assumptions about any of the things that have been done so far. Just ask it. If it has not been written down so far, ask people to actually write it down, or just ask people to bring you up to speed so you can write it down and keep a low context there. Because often enough, when you're debugging a distributed system, making assumptions about the things that have been debugged so far, that have been looked into so far, is one of the first mistakes everyone does. It's like, that's often the cause of things not being noticed in time. It's like, well, I would assume this guy already checked the config file, so why would I do that? I'm just going to assume the config files are good, and I'm just going to read the logs for 3 weeks, and then it turns out that the config file was wrong. And done that, been there. So yeah, don't make any assumption about any of the steps that have been taken. Just talk to people, make sure you all are on the same page and everything is being written down. And another good rule, especially in a system like OpenStack, OpenStack uses so many libraries and we have so many projects and so many things that are going on at the same time. And it's not just the services and the libraries, it is also the third-party libraries and the operating system it is running on. So everyone is guilty till proven innocent. Nova is guilty, RabbitMQ is guilty, Oslo, whatever Oslo library the project is using is guilty. Eventlet is always guilty, even if it is not guilty. It's fine, you can always point at Eventlet. The operating system, everything, until you actually find out what's going on in the system and you can say, well, turns out that it was not Oslo's fault, it is actually Nova's fault. Or it turns out there's an issue with the kernel and then working doesn't work very well. So it turns out that is not OpenStack in general, but just the operating system. But remember that when you're working on a distributed system, you have so many different pieces working together or trying to work together. And any one of those pieces can actually be misbehaving. So don't eliminate any of those libraries or any of those pieces from your equation until you actually found out the value of X. You gotta know the system topology. This might sound like obvious, but it's not really that obvious. Like if you, one thing that I always do when someone calls me into a debugging session, when I say a debugging session, it's basically someone saying like, oh, okay, we have a problem with this customer. Well, can you just look into it? It's not that Like, it sounds fun, and it sounds like saying debugging session sounds like doing pair programming and debugging the metrics, but it's not really that. It's just you sweating on the phone. And so one thing I do, if I don't know the customer and I don't know the environment, is like I spend quite some time understanding the environment. It's like, I know OpenStack, I know what Neutron does, and I know what Nova does, and I know how they work. But how did you deploy them? You know, how many compute nodes do you have? How many agents have you running? What agent are you using? So those are all things that I have to know to actually be useful to you and to help you understand what's going on in your system. I gotta know the topology of your system. I wanna know where each server is running. If it is running in Seattle, I wanna know that. Because, well, it turns out that network may fail in the US as well, and you never know. And if I ever have to run, I don't know, TCP dump, or I ever have to kill libvirt for some reason, I want to know where the compute node is, right? So you got to be familiar with the topology that you're analyzing and that you're debugging, so you know where to run TCP dump, and you don't end up running TCP dump in the API node, which is really dumb most of the time, not always. So, root cause analysis. I'm pretty sure many PMs and CEOs are going to be happy about this. Like I said before, many times the system is just misconfigured. Ooh, I'm running, okay. Many times the system is just misconfigured. It's happened to me several times that you start debugging a system. Well, especially when I started working on OpenStack, I was super happy. I was like, I'm going to tell you what's going on with Nova. It'll take me 5 minutes to actually tell you that. And well, after 3 days, I was like, oh, damn it, I don't know. And just go to look to the config file, and there was just a comma that was not supposed to be there. It's like, oh, okay. So that would have saved me like 3 days of debugging. So many times systems are just misconfigured. Look at the config files first. You know, you just open the config file. If you explain me the topology, I kind of know what it should look like, the config file at least. You know, if you tell me I'm using libvirt, I know what drivers are supposed to be there. If you tell me you're using Ceph and I open the Cinder config file, I kind of know or expect something to be there. If you're familiar, if you've done this often enough, you kind of like, there are some things that don't change. The host name might change, the IP address might change, but the values are supposed to be pretty much the same type and kind of things. So open the config file, take your time to actually go through it and analyze whether the config file is good or not. And if it's not, well, you just saved yourself a couple of hours. Have a list of steps to follow. And we're going to go a little bit in more depth on this topic, but it is good to know or to have a list of things you want to do when you start working or debugging a distributed system. It's like getting on a plane. Like when you get on a plane, you sit down on your seat, but you expect the pilot is going to go through the checklist entirely, right? You're not, hopefully he's not going to skip any of the steps there, because we might all die. And it's pretty much the same thing. When you start debugging a distributed system, you get the list of things you are supposed to do. It's like, check config files, done. Grab all the logs, done. Like, see if Nova API is running because I'm getting forward, done. Just go through the list of things that have happened to you more often, or that are all like often enough seen in OpenStack environments, so that you have to go through that, and that will save you some time, most of the time. Of course, it's not going to be exhaustive. It's not going to be perfect, and more often than not, you'll get to the end of that list and say like, well, this didn't help much this time. But you can always build up on that and add more items to that list. So there's bottom-up debugging. And again, I'm going to classify or divide or whatever you want to call it, this thing here, how you can approach the debugging session on OpenStack, although I really don't like classifying things. So you can do bottom-up debugging, which means get to the service at the bottom of the entire stack and start from there. Often when people calls and say Nova Compute is not running, or I don't know, like I'm a Glance guy, so I tried to upload an image to Glance and turns out the storage failed. Of course, I'm going to start looking at the storage before I start looking at the Glance API. This is great. This saves some time. It really depends on the issue. It really depends on the context of the environment and the issue you're trying to debug. But if the customer or someone says, well, I tried to boot that virtual machine and it just like randomly failed. Or I had like a set of virtual machines running, and out of 5, I now have just 2. So you probably just want to go to Nova Compute and try to understand what happened in that node. And then you can go up to the stack if you don't find anything there. You can also go top to bottom. And to do this, actually, you got to know the system topology, like I said before. And I'm going to stress this a little bit more throughout the presentation. You got to know what your system looks like. If someone says, I'm trying to hit the Nova API, or whatever API, I always pick on Nova. But I'm trying to hit the Nova API, and it's not working as expected. So I'm going to pick on Glance now. So that's actually happened to us. This guy said, I have a cluster of 3 Glance API nodes. I have 3 Glance API nodes running, and I created a set of snapshots. I created a snapshot of this image, and now I'm trying to boot a set of virtual machines out of that image, and I'm hitting the 3 Glance API nodes at the same time, or in parallel, or whatever. But 1/3 of the time, I'm seeing a failure. I'm seeing this error here, and of course he pasted the entire traceback on an email, because why? Like, emails are supposed to have tracebacks. And by looking at traceback, the error was pretty obvious to me because I'm a Glance developer. And it's like, this URL that you're trying to pull the image from doesn't actually exist. I don't know that scheme. You're talking to a store that I don't know how to talk to. And which translates to, you probably have one of the nodes misconfigured, and you have 2 nodes talking to Ceph, and the other one is just trying to talk to the file system, which of course doesn't have the image because you are using Ceph in the other 2 nodes, which is where you created a snapshot. So that was easy to me, because I'm a Glance developer and I know how Glance works. But of course, it wasn't obvious to the person sending the email. But what I'm trying to get to here is, I didn't go to the node, to the Glance API node, and started looking at it. I didn't go to Ceph and try to debug Ceph to see what was going on there. I was just like, well, you have 3 nodes. That's a topology. I'm going to go top to bottom here. You have 3 nodes here. 1/3 of the request is failing because of that error. This is probably what's happening here. Turns out I was right, but that was just a random guess, and I was lucky enough. But yeah, so that's something you can do, or you can just do, or you can just do monkey debugging, which is the one I like the most. If we go back to the example I used before, we have to kill RabbitMQ every 2 hours because it fills up and it's out of memory. So like, where do you start there? It's like, you don't even know, because it's like, so when did you reboot it the last time? Well, I was trying to create a volume. It's like, you go debug Cinder is all fine, it works perfectly, there's like no problems there. It's like, okay, so, well, call me if it happens again, because I didn't see anything. It's like, well, this time happened when I was trying to boot an instance. And it was like, okay, you go review Nova and say, it's like, nothing's happening here. So how do you debug that? So when problems happen normally when problems happen in third-party systems that we're using in the OpenStack environment and the OpenStack distributed system, you normally, like, well, I normally do is just monkey debugging. I just like, okay, RabbitMQ failed. Everyone sucks to RabbitMQ. It's like, it could be anyone. So you just like make your best guess. You go there, try to debug it. It didn't work. You go to the next service, debug it. Everything's fine there until you actually find the cause. And in the example I used before, it turns out the fault was the networking guy. It was not Neutron though. It was the kernel's fault. So anyway, but you do monkey debugging. It's like, what I'm trying to say is that don't get stuck on a single way to debugging this. Don't always go top to bottom. Don't always go bottom top, from the bottom up. And don't always do monkey debugging, because sometimes you don't really have to. But keep in mind that there's not a secret sauce for this. There's not a one solution that will solve all the problems. One other thing that is also super useful is correlating logs. There's this tool called OS log merge, and what it does is you can fit it, I think, a path to one of your servers or a list of servers, and it'll go to actually a path. You get all your logs from your server. You fit it to OS log merge, and it will merge all the logs using the timestamps, and you'll have a single file that you can go through that is ordered by timestamps, of course. And you have to have, like, of course, your servers have to use a common time server to synchronize their own time. So otherwise, you'll just get messages ordered in random ways. But it's actually super useful because if you're trying to debug, an instance boot call that failed, and turns out that the instance boot call had, I not only want the instance, but I also want this volume to be mounted there. And something goes wrong, and you don't really understand what's there. Like the error is not obvious because none of the errors are obvious in Nova. And you just get the log files, you merge them, and you can just read one single file. You don't have to, go through all of them. You can read just one single file and try to make reason out of it and understand in order what happened. So like at this point, the Nova API got the message, Nova scheduler, the Nova compute. Like I tried to create a volume. Like Nova tried to create a volume. Nova tried to multiply. I attached the volume and all that. But at least you can go in order, which is super useful when you're debugging a distributed system and you have log messages everywhere. It does not correlate logs from other services like RabbitMQ, but if you get to the point where you need to debug RabbitMQ, then you have a bigger problem. Just saying. Trace events throughout the system. We were really terrible. Like OpenStack was really terrible at this. I think it kind of still is, but it's gotten better. There was not real obvious way to track a request that went from Nova API and failed at some point. Like there was no way to go through the entire logs and see what happened with that request. There's a request ID now. Well, it's been around for a while actually, but of course you need all the services to read that request ID and put it in the logs to actually be useful. I believe most of the services, that the core services, do it now. So you get the request ID and you basically grep on the request ID. If you have your logs merged, it's even better because you just find on the same file. And you can trace that request throughout the system and see in which of the steps it failed. And of course, go and read the traceback there if there's a traceback, or try to understand what's going on and what happened. So tracing events throughout the system is critical, but you cannot do that if you don't have timestamps. And those are pretty much your life when you're debugging a distributed system. If you don't have timestamps, or let me put it this way, if you don't have reliable timestamps, you can have timestamps, but if your system is not syncing from the same time source, then they're not reliable at all. You're not going to be able to know what's going on there. So if you have reliable timestamps and all your servers are syncing from the same NTP server, then it's going to be not super easy, but it's going to be easier for you to trace a single request throughout the system and to understand when things happen. And what's important here is not the exact time when things happen. Like sometimes it is important. Like someone says, I had to kill it last night, and you have like 3 different events of the same failure in the log file. So you want to know that you're looking at the same failure and you're not mixing messages from different failures. But what's important here is the ability of ordering the events that happened in your system based on time, so that you know in which order they happened, and you can just go through the entire request and understand where the failure happened. Comparing executions is also super useful. And this is what we did, going back to one of the examples I mentioned, where the customer had to kill RabbitMQ several times, and what happened was that they were calling Nova, trying to get metadata out of it. It actually took us, I think, a week to understand what was going on there, because we didn't know there was this other service calling Nova. Whether what they were doing was right or wrong, I don't know, or useful or reasonable. I don't really care, honestly. The fact is that there was this service calling Nova, and we didn't know about that. And what we did is we tried to do a bottom-up debugging session, and we went to Nova and we tried to understand why the connection, the communication between RabbitMQ and Nova was failing. We couldn't find anything, because if that external load of requests wasn't hitting Nova, everything was working fine for us. It just happened whenever that service started calling Nova. And So we tried Bottomup and didn't work. Everything was fine for us. And we waited a little while until the thing happened again. It happened again. And we're like, okay. We started to see a pattern. And we saw that it happens like every 15 minutes. So there is something every 15 minutes that is causing this, massive amount of messages being stuck in RabbitMQ. It's not like they have to reboot RabbitMQ every 15 minutes. They happen to have enough memory in the server. But it did fill up the RabbitMQ queue, and of course the memory kept raising. So we kept debugging this thing, comparing all the executions until we saw the pattern. We told them, is there anything happening every 15 minutes in your system? And we're like, well, yeah, we're trying, every 15 minutes, we're trying to run this set of virtual machines, but we want to know what's going on in Nova before we do that. So we just query the API, and we get all these messages, blah, 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 and the email was super long. We were like, so can we have that code? It's like, we don't want to tell you to not do that. We don't want to tell you to stop doing that, but at least can we take a look at the code and see what's going on? No, the answer was no. So we were like, okay, there's definitely something going on here. So we had to wait every 15 minutes to actually debug the issue. So every 15 minutes we were playing our odds there and see if we could find what was going on until we placed a couple of. So luckily enough, they let us get into the environment. It was not a production environment. It was a production niche environment, and they let us in. And at the very beginning, the guy was driving, so we were on the phone, telling him what to do. So open this file, open this log, until we said, man, it's just give us access. It's that's gonna be super easier. So he the guy let us into the server. So every 15 minutes we tried to figure out what was going on in the system until we find that the connection leak and figured that we stopped consuming messages at some point for some reason. But again, comparing executions is sometimes useful when you really have no idea what's going on or why things are happening. So be patient and try to compare executions. Visualization tools are quite handy. There's nothing bad in saying that you cannot reason about the logs files and you cannot understand what's going on without visualization tools. Actually pretty useful when you want to understand the topology. At least that's what I do. And people start, well, we have 3 neutron nodes, we have 4 compute nodes, and we have so many storage nodes. Man, can you just draw it down, give me a diagram that I can look at? Because I don't even know how neutron works. So if you talk to me about we have that many agents, that was agents? Do we even have those in OpenStack? It's well, so if you show me the squares, that's super easy. This is neutron, this is the compute node, this is the API node. I'm okay, that I understand. That's super easy. So there's nothing wrong about getting things, thrown down for you, if you were a kid. It's fine. So bring it home. Some bugs are just hard to debug. Some bugs just, take longer to find. The one I just mentioned. It took us actually more than 1 week to figure out what's going on. Whether it was our fault, customer's fault, I don't really care. The fact is, it took us a week because the means that we were using to find the bug and the environment and all that didn't allow us to do it faster. And we didn't have enough information. So we were patient. We tried every 15 minutes for several nights, very late nights, until we actually found the issue. And again, it's fine. It really depends on what you're supposed to do there. And this is something we actually ask the customers, do you really want us to just bring it back up quickly? Because we can do that. You can do that. You've rebooted RabbitMQ 4 times already. So you know how to actually make it work again. So if you want us to find what's going on there, we'll need some extra time because we don't have this information that we need to find, and you cannot give us the code, and we have to figure out what's happening there. So some bugs just take more time. And if you're debugging a distributed system, you kind of can expect that bugs will take longer to find. But at the end of the session, you have to be able to describe what went wrong, what was completely fucked up in your system. And sometimes you can write super cool reports 4 pages long and explaining the root cause analysis. And sometimes you just say, well, this is the behavior, the system was failing, the network initiation I mentioned before. It's we don't know what was going on between RabbitMQ and Nova. We just know Nova was not reconnecting. We fixed that problem, which is an actual problem in OpenStack. The networking issue, that's the networking guy problem inside that company, you know? Like, it's not that we don't care. It's just like, as far as we are concerned, we brought it home. We said, this is what happened from an OpenStack perspective. This is what we did, and it works now. I'm not saying it's fixed because the networking issue was still there, but at least it works, and it works in a reliable way. So sometimes you fucked it up, sometimes other people fucked it up, but the real point here is that you have to be able to describe what was going on in the system. Build new tools for the future cases, like OS log merge. That was built out of by some guys that suffered going through different log files, and they said, like, well, it would be super useful to just have it in one file. So we're going to build this tool that will do that for us. So build new tools as you go. I'm pretty sure that every environment and every deployment of OpenStack is different. They might share some of their reference architectures and reference or common ways to deploy it, but there are many things that change in every environment. So build new tools that will make it easier for you. If possible, just put them online and make sure they are all open source so we can all contribute and benefit from them. Like OS log merge, for instance. You can go and get that whenever you want. And build a knowledge base. We definitely have a knowledge base of all the issues we've had, so we can just, when similar things happen, we can just go there. The knowledge base for us is basically the Bugzilla we use. But build your own knowledge base. Go and find other knowledge bases that are out there that you can learn from. And make sure you keep track of every issue that you've debugged so that you can go back to that in the future and read and try not to waste time on things you've solved in the past, especially when you have several customers using the same version of your product and it turns out that your product, you update your product, you have new releases, but you still have customers in the old ones. Well, you definitely want to have a knowledge base so you can all benefit from that and keep track of different versions and that kind of things. So, summary of everything we've said so far, or well, I've said so far. You've been silent the whole time. So have clear goals, know systems topology, keep a low context environment. Just remember, write everything down so that other people don't have to make assumptions about the things you did or you broke. Don't assume anything about anyone or about any of the steps that have been taken in the system. Keep the time small and contextualized. Build new debugging tools. Please do this. Build new debugging tools. We will all benefit from that. If you've suffered debugging OpenStack, I want to know about it. I'm pretty sure every OpenStack developer wants to know about it so that we can make it better or worse. Check configurations files too. Actually, do that first. Do that even before you read the log files. Don't know what to put here, and seriously, no clue what else I can say about it. So, references about all the things I've said. Books I've read, and there's this distributed debugging, pretty useful. Debugging deployed distributed systems, also another talk. The ETOP principle is a book, it's good. The programming ape, awesome talk as well. And lots of blood and tears. Questions? There's one.
I have one a little bit more operational troubleshooting question than a debugging question, because I define debugging as more as finding out what's wrong with an application or a specific service. But from an operational perspective, where I work is like in an enterprise environment, there are many coexisting services which generate the end user experience from an application point of view. You have, for example, I work with storage, and I always get blamed when something doesn't work because the obvious reason is that storage doesn't work, right?
Right.
And I always blame network, and they never get blamed without me actually challenging them so much that they are actually proven guilty. Otherwise, they don't do anything.
I have a cron job for that.
Yeah. But my point I want to ask you is what your experience when you're talking about an enterprise service delivery based on different operational teams, and then you run a virtualized environment on top of that. Where do you draw the line, and what advice do you have when you want to troubleshoot both the application delivering and also involve the delivery teams and the
That's actually a very good question, actually. Thanks. You didn't have a mic. So the question is, if you work on an enterprise where you have different teams working on different products and you all share the same environment, when shit happens, who do you call? Where do you draw the line and say this is not my problem anymore? We should call someone else. Or why do people don't call that person before calling me? That's a very good question. So. For me, debugging application, debugging an environment, that's debugging to me, right? So you still have a distributed system. You still have a set of applications working together. I guess we go back to the to one of the first slides in the section is like, what are we doing here? Just make sure the right people is there. So one thing I would say is like, and I complain about this, and this was actually kind of like fixed in the whole process that we have, is that if I find myself, so if we're debugging because I hit several projects in our stack, right? So I might get called for different things. But my point was, if you call me to debug a nozzle messaging issue, right? If you call me because RabbitMQ is not working, okay, let me back that up a little bit. So you don't get calls from people telling you RabbitMQ is not working, right? They'll tell you the instance is not booting, right? I tried to create a volume and it didn't work. So if the call is, I tried to get a volume and it didn't work, from the traceback you see RabbitMQ, the queue doesn't exist. That's a common message in RabbitMQ when there's a networking issue. It's like, the queue does not exist. I don't know where to put that message in. If I get called and I'm the only one debugging this system, although the original call was because they tried to run Cinder volume and it didn't work, and there's no one from the Cinder team there, well, we have an actual issue here. You got to make sure the right people is part of every call and the right people are trying to debug the issue, right? Because if I have a question about Cinder, luckily enough, I'm familiar with Cinder, but say Neutron, if I have a question about Neutron and how Neutron works and I don't have anyone to ask, that's going to waste time for everyone. And something I really hate is wasting my own time, right? Which is why we all develop all these fancy ways of debugging things and tools. So where do you draw the line is like at the very beginning. Like I'm not getting into a debugging session. I'm not even reading a Bugzilla if I've not seen a comment from someone on the Neutron team saying, this is definitely not a Neutron issue. I looked at the log files, not the traceback. The traceback lies like all the time unless it says I ran out of memory. That's something pretty obvious. But tracebacks normally lie. Like they show you the error, but many times they're just hiding the actual issue, right? So from the very beginning, like if I'm gonna debug in Bugzilla that says I didn't find the queue from a nozzle messaging perspective, and I don't see a comment from anyone on the Neutron team that says I read the logs, this is definitely not a Neutron issue, we need someone from the messaging team to look at it, well then I'm not reading the Bugzilla to begin with. So bring the right people in place and then we can all work together towards a solution. And the same thing applies to me. When one of my services, like when Glance fails, it's like I'm not gonna call random guys to debug my issues if I know it's a Glance issue, right? So I try to read the config files, read the logs, and if definitely not a Glance issue, then I'm gonna start calling other people because I don't want to be the hero. I just want this to be solved as soon as possible. So I'm not gonna try to debug Neutron when I'm not familiar with Neutron. So if I believe it is a Neutron problem, I'm just gonna call someone from the Neutron team and say like, well, this came in as a Glance problem. I believe it is a Neutron problem. So can you help me figure this out? Does that answer your question?
Yeah, a little bit. So you can conclude and say that, well, my conclusion is that when you have an enterprise environment, a troubleshooting solution, troubleshooting action can be really scary when you have this kind of field. We have physical storage, we have physical network, and we have physical nodes. Now we're adding an extra layer with virtualized everything.
Right.
And you don't know if it's a virtualized network problem or a physical network problem.
Right, but you got to start somewhere, right? Yeah. So you start whatever the customer told you the issue is, right? So that's where you start from. If that's not the issue and it is obvious for the person, for the the frontline person that is not a problem on that service, then you start calling the backup and to actually help you out with that. And the answer is you got to fix your process. There's no technical solution for this. This is entirely an enterprise process problem that you got to fix. Other questions? So you all know how to debug OpenStack. That's cool. That was the goal. Thank you all.